In this example, we're going to be looking at a graph of concentration versus time. And this is going to be a graph that represents the chemical reaction between nitrogen and hydrogen to form ammonia. We're going to have three lines, one representing each of our reactants. We have the hydrogen, the nitrogen, and our product ammonia. What we're interested in doing is calculating the instantaneous rate. We're going to look and say, what is the rate that the chemical reaction is taking place at 150 seconds? So what we're going to do is we need to draw a line tangent to the curve at that 150 seconds. So if we do that first for the nitrogen, we have a line that's tangent, and we want to figure out what is the slope of that line. So we're looking for the horizontal, which is going to be 100 seconds if we look at that change, and the vertical, how much has the concentration changed. So we can draw that vertical line, and that's going to be a change of negative 0.005. The nitrogen as a reactant in this example is being used up. It's being consumed during the chemical reaction. We know that the rate can be calculated by taking the change in concentration, our negative 0.005, and dividing by the change in time. That gives us a rate of negative 5.0 times 10 to the negative 5 moles per liter second with respect to nitrogen. Now, what we want to do is we want to compare that to the rates in terms of our other chemicals. We want to look at the hydrogen at that exact same point in time, and we want to draw another line tangent to that point. And we again want to look for the horizontal time change and the vertical concentration change. In this case, the same amount of time, 100 seconds, but our concentration is negative 0.015. Again, the rate is the change in concentration divided by the change in time. But this time, that calculation gives us a value of negative 1.5 times 10 to the negative 4th. It's important to note that this rate is 3 times the rate for the nitrogen. And that rate for the hydrogen is 3 times because it has a coefficient of 3 to the nitrogen's coefficient of 1. So that our rate for hydrogen is 3 times the rate for the nitrogen. Finally, we can look at our product, the ammonia, and again, at that same 150 seconds after the reaction has started, we will have a line tangent to the curve, and we're going to look for the same horizontal and vertical changes. And again, our time is 100 seconds. This time, the concentration change is a positive 0.01. That positive indicates that we are creating nitrogen. When we look at the rate, we have that concentration change divided by the time, giving us a positive rate of 1.0 times 10 to the negative 4th. Again, this rate is double the nitrogen. We have double the nitrogen because the ammonia has a coefficient of 2 to the nitrogen's coefficient of 1.